EDX Core Pure, Complex Numbers 1, Introduction, Dividing Complex Numbers. Before we look at dividing complex numbers, we need to just look at an aspect of multiplying complex numbers. So if you think of 5 minus 2i times 5 plus 2i, so each bracket is a complex number. But when we expand the brackets, we get 5 5s are 25. We get minus 2i times 5 is minus 10i. We get 5 times 2i is plus 10i. And then we get minus 2i times 2i is minus 4i squared. So that's 25. Minus 10i plus 10i have cancelled out. And minus 4i squared is minus 4 times negative 1 is plus 4. So we get 29. The important thing about that calculation is that when we multiplied 5 minus 2i by 5 plus 2i, we got the answer 29, which is entirely real. So you may recall using the difference of squares when factorising and when rationalising surds. This is a very similar method that you're going to use now. Notice it's 25 plus 4 to get the 29, and the answer is real. It's also worth noting that 5 plus 2i and 5 minus 2i are known as complex conjugates of each other. So we can use the fact that multiplying complex conjugates gives a real number to help us in our divisions. So here we've got 3 plus 2i over I, and we want to simplify this problem and actually do the division. The thing to remember is that I is a special kind of surd. It's just the square root of minus 1. So if you think about how you would tackle this if we were just dealing with surds, then I hope you would think about multiplying top and bottom by, in this case, I. I is just a surd. So the top is 3 plus 2i times I, and the denominator is I squared. So now we can expand the top, so we've got 3 times I is 3i, plus 2i squared, all over I squared. And we're not allowed to cancel out i's or I squareds here, but we can simplify the numerator and the denominator. So we've got 3i, I squared is minus 1, times by the 2 is minus 2, and I squared in the denominator is again minus 1. You wouldn't normally leave the answer in that form. If we divide the top by minus 1, then it would become minus 3 plus 2, and again you wouldn't normally put the imaginary part in front of the real part. The standard approach is to put the real 2 before the imaginary minus 3i. So we get 2 minus 3i. If we look at this slightly more complex problem, we've got 4 plus I over 2 plus 3i. And again, remember I is a special kind of surd. So what would you do with a problem like this using the methods associated with surds and rationalising? I think we would take this fraction, we would look at the denominator, and we would multiply top and bottom by what is called its complex conjugates. That's 2 minus 3i. Don't forget to change the sign. And you do the same to the top. So in effect we're multiplying by 1. So we've got 4 plus I, we need to multiply by 2 minus 3i, and in the denominator 2 plus 3i, and we're going to multiply it by 2 minus 3i, its complex conjugate. So the top becomes 2 4s are 8, we've got I times 2 is plus 2i, we've got 4 times minus 3i is minus 12i, and then we've got I times minus 3i, so that's minus 3i squared. The denominator, we've got 2 2s are 4, we've got plus 6i, we've also got minus 6i, and we've got minus 9i squared. Notice the plus 6i and the minus 6i will cancel out. If they don't cancel out, something has gone wrong with the method. Make sure that those terms cancel out. So starting to tidy things up, we've got 8, we've got 2i minus 12i, so that's minus 10i in the numerator. We've got I squared is minus 1 times minus 3 to get plus 3. And if we look at the denominator, we've got I squared is minus 1 times minus 9 is plus 9. So the denominator is 4 plus 9. So tidying up a bit further, we've got 11 minus 10i over 13. But if you look at the problem was to write the answer in the form a plus bi, where a and b themselves are real numbers. So we just need to take this a step further and separate this into the real part, which is 11 13ths, and the imaginary part, which is minus 10 13ths over I. So make sure, if required in the question, you do give the answer in the form that is expected. So in the next session we'll be going to be looking at terminology, real and imaginary parts and conjugate pairs.